Alright everybody, time for a few examples that use rectangles and squares and their properties to help us out. Rectangles 1's going to get into a little crazy territory with some older math that we've seen. You'll see where that's going. So let's dive right in and figure out what's going on here. So we are told that the measure of angle PTS is 34. That's already drawn in for us. And we're told that QS, which is the length of this diagonal here, we're told that it has a length of 10, and we need to find the indicated measures. Okay, so starting with SRT, that angle up there. Well, one thing we know about the angle SRT, which is that one, is that it's the corner of this triangle right here. We know that this angle here is 90 degrees because in rectangles all the corners are 90 degrees, and we know that this one here is 34. So we can do 180 minus 90 minus 34 gives us 56, and we know that that is the measure of angle SRT then. So that's a good one there. So now we need QPR. Okay, well, since we know that this is 56 degrees, then we know that the other side of it is also 34 degrees. Now, given that rectangles work the way that all of the diagonals are split into these even pieces, we know that since this angle here is 34, this angle over here is also going to be 34 degrees. Which means, here we have another triangle. If we want QPR, we just have to do 180 minus 34 minus the other 34, which will give us 112 degrees. So there we have those two angles. And now we just have to find some side lengths. Okay, first off, QP. Well, we know that all of QS is 10, which means that if we take these halves, that's 5, that's 5. And remember, rectangles are special in that their diagonals are the same length. So we know that this is 5 also, as well as this. So, knowing that, we can easily see that QP has a length of 5. And we can see that RP also has a length of 5. So, those are helpful. Now, when it comes to finding QR and RS, we're going to have to, this is where things are going to get a little crazy. We got to think a little back for this one. For QR, for example, so here's QR. We can say that QR is part of this right triangle right here. And given that this is 34 degrees, we know that this up here is going to be 56 degrees. There's our right angle. We also know that RT has a length of 10 overall. That's the hypotenuse of that right triangle. And we're looking for RQ. Notice what we have set up here. We have a right triangle with an angle and a side, and we're looking for another side. This is trigonometry. So, what do we want to set up here? Well, what sides do we have for this 56-degree angle? Looks like we have our opposite side and our hypotenuse. So, katoa means that we want to use sine here. So we're going to set up sine of 56 equals x over 10, multiply both sides by 10, and we'll get that x, this is for this problem, equals 10 times sine of 56, which, when we type into our calculator, is going to give us about 8.3. So this length up here is about 8.3. Now, to get RS, we could use trig again. We want that side next. So let me erase everything except for the new length that we have. We know it's about 8.3. So we could set up a different right triangle, like this one. If we know that's 8.3, we're looking for this one. We know this is 10. We can use Pythagorean theorem to find RS. We'll just set up 10 squared, that's the hypotenuse, equals 8.3 squared plus our missing side, RS squared. 10 squared is 100, and we're going to subtract 8.3 squared from that. That gives us about 31.11 equals RS squared. So we'll take the square root of that answer. And we find out that RS is about 5.6 in length. So, even though we're on these new topics, a little bit of the old mixing with the new ideas. Let's move on to the square problems. So there they are. So the diagonals of square LMNP intersect at K. Given that LK, just that half, is 1, find the indicated measures. All right, this one's going to use a little bit of old stuff too, it looks like, maybe. Okay, so the measure of MKN is the first thing that we want to find. So MKN, well, that's not a bad question. Since this is part rhombus, remember rhombi have their diagonals perpendicular to each other, so we know that MKN has to be a 90-degree angle. So that's not too bad. LMK. Okay, well, for LMK, different angle we are looking for. Well, for that one, what we're going to do is, we know that since this diagonal side is 1, this is also 1, this is 1, and this is 1. Notice that this here is an isosceles triangle then, and has two sides that are the same length, which is good. So what we can do with that is we know that these two angles here are going to be congruent. Since 90 degrees is the angle in the center of the triangle, there are 90 degrees left. These two angles are equal, so 90 divided by 2 is 45. LMK is 45 degrees. And LPK is, well, basically in the square, all these corner angles are 45 degrees for that very reason. So LPK is also 45 degrees. So that's good, and not too bad as far as information goes. Now we want to find the length of Kn. Well, Kn is 1, since all diagonal halves will be 1, since the first one was. This is true for squares and rectangles, remember. MP will have a length of 2. And LP, well, just use Pythagorean theorem. Here's our right angle. Here's what we're looking for. That's the hypotenuse. So we'll just have 1 squared plus 1 squared equals x squared. That's 2 equals x squared, so x has a length of root 2. So LP has a length of root 2. And that's all there is to that one. So, hope you found this informative. Videos on the unusual shapes of kites and trapezoids are coming up next. So, keep on watching. See you in the next video.